Assalamualaikum and salam sejahtera. Hello everybody, I'm Hana from Vision College. Welcome to another session of SPM 2021 Booster Meet, specially brought to you by Vision College. Knowing that the SPM is around the corner, today's special session for those who want to score better in physics. So for this video, we'll be doing physics subjects for the topic of motion that is covering in Form 4 syllabus. Okay, so without further ado, I will share the screen and show you the documents. So here, as I mentioned just now, I'll be doing the topic of motion. Okay, so to understand the topic of motion here, we need to know the three parameters that is essential in the topic. That is displacement, velocity, and also acceleration. Okay, so between these three parameters, these three things, they are actually interrelated from one to another. Okay, so you guys have learned that velocity is also the rate of change of displacement, or is easily said in terms of formula, that is velocity is equals to displacement over time. Okay, while acceleration is velocity over time. So we can see the word velocity here exists here as well. It means velocity, to get acceleration, we need the velocity. To get the velocity, we need the displacement. Hence, the reason why I say just now that between the three parameters here, they are all related to each other. And how they are related to each other is by time. So what makes one different to another is the time itself. Okay. So now I'll show you the relationship between the three parameters. Okay, so the first one is displacement. Okay, so displacement is shown or symbolized as the small letter s, while velocity is v and acceleration is a. Okay, so as I mentioned just now, from displacement, if we are from displacement, how can we get velocity? Is velocity against, what is the formula for velocity? It's displacement over time, or displacement divided by time. So if we have displacement, we divide by time, we get the velocity. If velocity, we divide by time, we will get an acceleration. And the opposite of division, we know that it is multiplication. So if we have acceleration, we multiply with time, we will get velocity. While velocity, if you multiply with time, we will get displacement. Hence, the three of it are related to each other. So between these three, displacement will be the smallest unit, basically, the simplest unit, easily said. Okay, so if you want to go into the analysis of motion graph, right? So it does not have the multiply or the division part. What we have is usually, how can we calculate something? By looking at the gradient or even the area under the curve of the graph, okay, under the graph itself. Okay, but before we go to the graph, we have to know the basic formula. What does it mean by gradient? So you guys have learned this in maths. Okay, to find a gradient, we have this formula, which is y2 minus yy over x2 minus x1. So what is the y? What is the x? The coordinates, basically. Okay, the y2 minus yy, x2. The coordinates on y-axis, the second point minus the first point, the coordinate of the first point, okay, on the y-axis, and for the x-axis and so on. Okay, while for the area, when we want to calculate the area, we have to look at the shape of the curve itself. Okay, the geometric shape. So if it's a triangle, we have to follow the formula for the area of triangle. For example, half times length times width, right? Or height lah, whatever. All right. So if it's a square or it's rectangle, so it means width times length and so on. So you have to look at the geometric shape. If it's trapezium, so you have to follow the area, the formula for the area of a trapezium if you want to calculate the area. Okay, gradient, we use the same formula. But for the area, it depends on what shape it is. Okay. Next one, we want to look into the example. How, if we have a question like this, it is displacement versus time graph. So when you look at the graph, you always read it by the y-axis. We know the vertical line is the y-axis, right? And then the horizontal line is the x-axis. So for this one, the y-axis is the displacement. So it is displacement against time graph. All right. So, and we can see that the graph is directly proportional. It means it's straight up, but at a slanted position. It is slanted. All right. So at each time, it has its own displacement. It means what? It is moving. All right. The object is moving. If the object is following this graph, it means while at 2 seconds, the object is at the position of 0.5 meter. At 4 seconds, position changed to 1 meter. At 6 seconds, it changed to 1.5 meter. And while at the 8-second mark, the object is at the position of 2 meters. So we can see that the object is moving. Okay, so if you see the object, sorry, the graph is in a proportion, it's increasing like this. It means that it is in motion. It is changing position. That's why we can see that it is changing position. All right. So for example, we know that it is changing position. It means it's moving. Changing position means it's moving. How do I know? Because the value here changes as time goes by. All right, and then now, so how can I calculate the velocity? We know velocity is basically what? It is basically the speed of the object. How fast it moves, basically. Okay, so how can we calculate the velocity? So if you are confused how to calculate it, you look at this one again. Since our graph here is displacement, you look at this, displacement against time graph. So if it's displacement, we want to find the velocity. So what should I do? I have to find the gradient. So what is the formula for gradient? This one, y2 minus y1 over x2 minus x1. So since the y-axis is our displacement, so the second displacement minus the first displacement, the second time minus the first time, basically. All right. So if, for example, the question asks us calculate, for example, I write it down here, calculate the velocity when time is, for example, 0 second to time equivalent to 8 seconds. For example, if the question is asking like this, we know velocity. Okay, again, you just need to remember the relationship between the three. So again, I write down at the side here S, V, and A. S is displacement, V is velocity, A is acceleration. So from displacement to velocity, I have to divide by time, or in terms of graph, I have to calculate the gradient. Right. So again, the graph, we look at the question, it gives us the information about displacement. And the question wants us to find the velocity. So what should I do from the graph is I have to calculate the gradient. So gradient from which point to which point? So since the question asks from t equals to 0 second to t equals to 8 second, so this one will be when the time is 0 seconds, this is our first point. This one will be our second point. Okay, so since it is velocity, so the velocity, the formula will be finding the gradient of the graph, T2 minus T1. Okay, just now I mentioned that when we want to find the gradient, we have the formula of gradient y2 minus y1 over x2 minus x1. Why suddenly I do it like this? Because our y-axis now is the displacement, our x-axis is time. Hence, I change it here. Okay, so since I know the point here is this one and this one, how to find the velocity? S2 is the second point here, 2.0 minus S1 is 0 meter over time. Second point here, the time is 8 here. 8 seconds minus, for example, this one is meter, minus 0 second. So 2 minus 0 is 2 over 8 minus 0 is 8. So 2 divided by 8 is 1 over 4 or 0.25 meter per second. Make sure in physics, you do not forget to write down your unit. Okay, it's meter per second. Hence, you can get the value of the velocity of the object that moves according to this graph. Okay, so when you want to find it, you just have to remember, let me clear this one up. You just have to remember the relationship here. This is vital. As long as you know the relationship between one and another, it will be easy for you to analyze the motion graph. Okay, so remember displacement going that way, or displacement to velocity to acceleration, you have to find the gradient. The opposite side, you have to find the area. Okay, in terms of calculation, it's basically you have to divide by time. If you want to go from the smallest to the biggest value, or if it's vice versa, you have to multiply by time or find the area. Okay, so now, since, okay, in exam, for example, the question won't be as simple, isn't it? So sometimes the question, okay, the question doesn't necessarily give us this kind of line. It can be a horizontal line, it can be constant, it can be increasing with a curve. So how can we identify that? So I have, what I have here is the summary of all the graphs that is possible. Okay. So now, since we know the relationship between one and another, which is from displacement, we can get a velocity. From velocity, we can get an acceleration, isn't it? So we can guess the shape of the graph by just having this summary of graph. Okay, for example, if the velocity is directly proportional, you will get, when you calculate your acceleration, it should be a constant, positive constant acceleration. Okay, if it's increasing. Okay, this one is directly proportional increasingly. All right. While the displacement will be looking like this, it will be increasing with the curve. Okay, it is not directly proportional. It is not 1 to 1, 2 to 2. No, it will increase at a different rate as compared to this one. Okay, so what you have to do is you need this summary of graph. I have 5 rows of it here. Let me zoom out a bit. Okay, so basically what this graph is, you just need to know. If you remember this graph, it will be easy for you to tackle this, this chapter. Okay, to analyze the graph especially. Okay, so if you see that velocity is increasing directly proportional, it is directly proportional. So you should know already that the graph for displacement will be looking like this. Okay, so how we can read this thing. Okay, again, like I said, displacement to velocity to acceleration, they are related to each other. So if your graph of displacement is increasing like this, you should know that velocity will be looking like the directly proportional. What is the value here? We do not know for sure. That one, you have to calculate it. Okay, calculate the area or calculate the gradient. So as I said, if you can predict your graphs by looking at the relationship between one graph to another. All right, so as an example, just now, we have our example where our y-axis is displacement against time. So with the graph of displacement against time looking like this, I can imagine, I can predict how does the graph look like if it's becoming velocity against time or even acceleration against time. So how do I know? By having or looking at the graphs here below. Okay, so just now from the example, our displacement against time is looking like this, right? It is directly proportional. So if the displacement against time is directly proportional, our velocity, we know it will be constant. Constant. How do I know? Because this is how it relates. Anything that is directly proportional, the parameters after that, it will be constant. So if displacement is directly proportional, the velocity will be constant. If the velocity is directly proportional, acceleration will be constant. Okay, so what if the velocity is constant? What happened to the acceleration? Acceleration will be zero. Because why? We know that the acceleration means the increasing of velocity. If velocity constant, constant means what? It is the same throughout. It means it doesn't change, isn't it? The value is the same. So if the velocity is constant, it means it didn't change, hence acceleration will be zero as well. Okay, so as you can see here, by looking at these 9 graphs, we can actually look that there is a pattern. There is a pattern. Okay, so if it's directly proportional, the parameters after it, which is the acceleration, will be constant. Before it, it will be increasing. Okay, and after a constant graph, it becomes zero. The same thing as this one. If the displacement is constant, what does it mean by the constant displacement? It means it didn't change. Over time, I'll stay at the same position. I stay at the same position. So if I stay at the same position, it means I did not move. So if I did not move, it means there is no speed. Hence, that's why it is zero here. If there is zero velocity, it means it's zero acceleration as well. So from here, we can see that there is a pattern. Okay, so when you want to figure out how your graph looks like, or if the question asks why or how does the above graph will be looking like if it's, for example, velocity against time. So you can predict it by having these 9 graphs. But on top of these 9 graphs, I have another extra 6 graphs, extra 2 lines, 2 rows of graphs here, which what happened if the displacement is decreasing over time? It will become, the velocity will become constant negative velocity. But again, whatever is constant, afterwards it becomes zero. Okay, anything that is constant afterwards becomes zero. Negative velocity means what? It slows down, isn't it? It slows down. So it slows down at the same, it slows down but at the same speed, isn't it? The speed is the same but it's negative. Hence, the acceleration is still zero. All right. What if the velocity is inversely proportional like that? So what happened? Again, the acceleration will be constant but negative. So if you can see here, if I zoomed out a little bit, you can see there is a pattern here. So whatever question that come out for the motion, for the topic of motion, especially about the graph, you can predict what happened towards it. Okay, so for example, I have one example of question here. So for example, here it says This is the, it says here, Aslan, this is a graph of Aslan's cycle along a straight road. The graph illustrates his motion. Okay, so we have a displacement against time graph. It means this is the position of him against time, over time, okay, as the time goes by. Okay, so for example, if the question asks, calculate the velocity of Aslan from t equals to 0 second to 35 seconds. So from here until here, what is the velocity? So how can I find the velocity from displacement time graph? Again, look at the relationship from displacement time graph. I want to find velocity. So what I have to do? I have to find the gradient. Okay, the gradient of which line? Okay, so since we have a lot of lines here, so we can differentiate it by each line. So the first line, the A to B point is the first line, second line B to C, C to D is the third line, and D to E is the fourth line. So again, how can I calculate the velocity? I calculate for each line by using the formula of gradient, and we can find out the value for each point, from one point to another point. So for example, the velocity from point A to point B, I calculate the gradient, right? So S2 over S1, T2 over T1, minus T1, sorry. So you get the value. So you calculate on your own, so you will get the value. Okay, so what if the question asks, draw the velocity against time graph that is based on this graph? So what happened? So since we have calculated this one, we can draw or sketch a graph out of, sketch a velocity time graph out of what we have calculated here. All right. So we know that from point A to point B, which is from 0 second to 10 second, the velocity will be positive 5 meter per second. So we sketch a graph. So how do you sketch a graph? Again, you must have your y-axis and x-axis. So the x-axis always time, which is the SI unit will be second. What about the y-axis? Since we want a velocity against time graph, we will have velocity lah. So the velocity SI unit is meter per second, isn't it? Okay, so the value here, okay, the x-axis here, the timing here, it will be the exact as the question. So if you look at the question, the x-axis, we have 0, 5, 10, 15, 20, 25, 30, 35 seconds, isn't it? It's a 5 second interval, right? And then the y-axis is displacement. But since the question was the velocity against time graph, the time will remain the same. However, the y-axis, which is the velocity, will change. It won't be the same as this one anymore. So what it is based on? It will be based on what we have calculated here. So we calculated that our velocity, the first 0 to 10 second, it is 5 meter per second. 10 to 20th second, it is 0 meter per second. 20th to 25th second is negative 7.2 meter per second, while 25th to 35th second, our velocity is negative 1.4 meter per second. So these values, the answers here are the one that you have to put in the graph. Okay, so the graph here, it says from 0 to 10 seconds, the value is 5. So it will be straight 5. You cannot do from 0 to 10 seconds. You do it like this. Cannot. Why? Because we know that the line here is directly proportional, isn't it? It is increasing. So displacement versus time graph, it is increasing. Now we want to do velocity time graph. If it's increasing, the velocity time graph is constant like that. So if it's from 0 until 10 seconds, this one will be 0 until 10 seconds. The whole thing must have the same value. Hence, the reason why, even though the answer here is 5 meter per second, it is 5 meter per second in the graph from 0 until 10 seconds. Okay? So the same thing as the following. So from B to C, which is from 10th second to 20th second, it is 0 meter per second. So from 10 second to 20th second is 0 meter per second is 0 here, right? And so on and so forth. Okay, so we know that this one, it is going downwards here. If you look at the graph here, if displacement going downwards, our value will be negative. So this is negative, correct lah? We do predict it, right? We can predict. That's why I said the graph here, these 5 rows of graph is a cheat code for you to predict what is your graph will be looking like in another parameters. What if the y-axis changes? Okay. So I hope that you can learn something from my lesson today. And with that, I will finish the video here. And with that, thank you for watching today's video. Today's session, again, is sponsored by Vision College. If you have any questions, please feel free to drop your comment here. We will answer your question. You also may visit us on our website at www.vision.edu.my. Until then, thank you guys.
If you like the video, remember, don't forget to subscribe to our channel
and press the bell icon for more updates.
Please share it to your friends and family.
See you in the next video.